we'll start recording this. This is 2/4/15, and we're talking now about why the biomes that we see exist where they do. So we're noticing that there are lots of tropical rainforests around the equator in this sort of equatorial band here. And we've got some there that aren't shown as clearly. We've got this band of tropical rainforests. The hottest, wettest biomes we can find. So here's this interesting thing. Well, first of all, let me say this. If we have a mass of air, okay, don't think of this as a cloud. It's literally a mass of air. This is notes. You would want to write this down. Remember, there's a cake on the line now. Okay, if we've got a mass of air, I'll pause while you get yourselves organized. If something causes that mass of air to rise, guess what happens? It rains.
So it collects enough condensation from the water?
Well, because of changes in both temperature and pressure. As any mass of air rises, the water vapor that's present there is converted to liquid water, and we see precipitation. So whenever we have a mass of air that rises up in the atmosphere, whether it goes up 100 feet or 1,000 feet, the farther it goes up, the higher the chance of precipitation is. So rising air masses tend to give rise to precipitation. Okay, well, that's easy. Doesn't explain why we have a bunch of tropical rainforests at the equator, does it? Ah, well, maybe this will. So here's our old friend, the Earth. There's the belt line, the equator. The equator is halfway between what two things? The poles. Air tends to flow, that way, if it was completely uninterrupted. Okay? Well, when that air meets, guess what happens?
Tornado.
Nope. It rises. So we get this band of precipitation, and I'll color it in sort of blue. We get this band of precipitation around the equator. We get this band of moist air masses. Now, there's another factor here too, and somebody alluded to it. Somebody said, well, there's a lot of ocean and a lot of heat, so water evaporates. Well, it's true. Anytime you've got a big body of water, that big body of water puts water vapor into the air because water evaporates off it. Very often, we get snowstorms in the winter that they call what effect snow? Lake effect snow. Guess which lake it is? Erie. Erie is a nice big body of water that puts moisture into the air. Those air masses that have lots of moisture move over land, and they dump that water on us. In the winter, that ends up being as snow. We get air masses traveling off Lake Erie that put snow a little bit further north than here. But we're south of the real lake effect band, but the same thing happens here at the ocean. So we've got two things happening. We've got rising air, and if you take a look here, look at how much of this space is ocean. So you have two factors. You've got air coming together, and when it rises, it's got lots of moisture in it because it's rising largely off the ocean. So we get this band of warm, wet areas at the equator. Okay. Well, what other patterns do you notice on this map? Let's see. Let's go back to the black. Huh, this is weird. Look at this big chunk, and look at this big chunk.
Desert.
And look at this big chunk, and this is all kind of desert. That's odd. So it's like we've got this really warm, wet area, and then above it we have sort of deserts. Why? Or dry areas. I mean, in some places, here we have grasslands. Here we've got some grasslands where you're not too close to the ocean. Why? Well, funny you should ask. If we go back to this, so I oversimplified. We do that. Air can't flow all the way down from the poles to get to the equator because the Earth is rotating. And so what you actually have is you have air that's sinking here and then being driven up and rising. So you've got these weird little cells. So like here, the air is all rising. Here, the air is sinking down. And then that same air will get sucked up and it'll rise. It's like an amusement park ride. You get sucked off the downdraft and you come up on the updraft. So we've got falling air here.
Wouldn't it be like convection currents?
It is actually, it is convection currents, but it's more complicated than that because you also have what's called the Coriolis effect. So there's more than one thing going on. They're called convection cells. So within this cell, you have warm air rising. Within this cell, you have cold air sinking at the upper atmosphere, but they sort of get sheared off because of the convection currents. So you've got sinking air here. Well, remember, we said when air rises, it tends to create precipitation. When you've got air sinking, it tends to be drying. It will actually end up absorbing moisture that's present at ground level. So we get this big band, we'll do this in brown, of much drier areas. There. It's still fairly warm, but we see a band there because we've got this big global circulation pattern. We're going to go back to the map here in a second. No. Okay, so up here we see more rising air. We do see a little bit more precipitation. That gives us enough moisture to have deciduous forests. It gives us a little bit more moisture so that we can have the pine forests of the north. There's North America roughly. So we've got deserts. We've got grasslands. We'll color those in sort of a yellowish color. A lot of this area is grasslands. And then we've got that beautiful, beautiful stuff that we know. What is this area? Deciduous forest. Most of the eastern U.S. is deciduous forest. We get too much further north, we get into the pine forests. Why do we have this drier area here? What happens? Well, part of it is exactly that. This middle of the continent, this whole middle of the continent, despite whatever big, larger global forces there are, you got a big old ocean here. That effectively can bring water to this side of the continent. Now there are some exceptions, and we're not going to get into mountain ranges and what mountain ranges do, but mountain ranges totally change the picture. The Pacific Northwest, they talk about dry side and wet side. The wet side is between the ocean and the mountains. All the moisture gets pulled out of the air by the mountains because the air rises up the face of the mountains. It drops all its moisture. The wet side of Oregon and Washington is a temperate rainforest. It rains all the time. You go over the mountains and you're in a desert because precipitation